So if I'm gonna talk about IPv6, I might as well start at the beginning, sort of where the idea came from, why IPv6 in the first place, and sort of what it looked like back when it initially started out. So to start off, like IPv6 is kind of older than I am, older than a lot of the students in this course are. The initial idea and sort of working group was formed back in 1993. And that was, and they sort of, I guess, got together, built up their recommendation, and were able to produce something by 1995. So by 95, you essentially had, although not the exact specification, you had some initial recommendations, and so of course the people working on Linux kernel had it implemented by 1996. It's kind of ridiculous. So the actual sort of RFC defining the spec came out in 98. Just before that, Microsoft Research was able to put something out for Windows NT. At first I thought, since it was 1998, like they actually got IPv6 implemented in DOS, but that wasn't the case, unfortunately. So, but they got their initial support out in 98. By 2002, they had what they were calling production grade support for IPv6 in Windows XP and in Windows Server 2003, a couple months later. And Apple was pretty much there as well. I can't find any sort of first-hand accounts of Apple being on board, but that's Apple for you. Like their documentation sucks now, it sucked then, and especially when it comes to anything that's like actually technical about their stuff, they just are not helpful, even with the Wayback Machine. So, but getting back on topic a bit, it looked like basically everyone had IPv6 support by 2002, 2003 or so in what they were calling production quality. Even Cisco had stuff out at this point, and from what I could tell, like some of the major like US ISPs were starting to eye it. I'm not sure why it took them so long to do anything public facing, but I guess for the most part it's just because public demand wasn't there. I mean, 2002 we were using, I don't think, even half the address space of IPv4, so yeah, no particular pressing need. So of course people were still working on it. IANA got some proper support of their sort of root name servers by about 2006, and actually some of the major world governments were putting out memos in the mid-2000s in terms of like, hey, let's get this thing implemented, let's get this thing out there. I know the US government had their backbone of their networking all IPv6 capable by about 2008 or so. The EU was targeting about 2010 for 10% of like everything being IPv6 capable. I'm not quite sure if they achieved that, but from what I can tell, they are well on their way. So many of EU countries rank pretty high in terms of IPv6 usage, like compared to the other countries out there. So yeah, it's crazy to think, but at least from the consumer side, things have been going and being pretty steadily implemented, essentially since IPv6 was a thing, and it's really been the fault of, well, not the fault, but like network admins just haven't bothered implementing it or have taken their time implementing it. And probably that's not a bad thing. So take your time. It's essentially a second internet over the same physical hardware. So take your time, do it right, and maybe we'll have a little less duct tape holding everything together for this one. So I'm gonna jump forward a little here to the beginning of the 2010s, and this was kind of a big time for IPv6 deployment, because at the beginning of the decade in 2011, actually marked in the middle of 2011 was World IPv6 Day. Now this was a huge event. Had hundreds and hundreds of corporations sort of getting involved in some capacity, and essentially what it was is, for a day, they would turn on IPv6 on for website services. It was like turning it on for their websites, for ISPs. I assume the details aren't entirely clear for them, what they did, but I'm going to guess like they just turned IPv6 on for their customers and would see what happened. And so it was just a massive coordination between, I don't know how many organizations per exactly, kind of lost to history, but yeah, it was probably one of the biggest single day coordinations arguably in modern history, which is huge because a year later they pulled it off again, and they pulled off something bigger. Essentially, so in June 2011 they pulled off IPv6 Day, where they turned on IPv6 for the most part just for the day, see what would happen, and then turn it off, go back, sort of work on stuff. In June 2012, they turned stuff on permanently. So from the sort of archived website, it shows there were over 3,000 websites participating and 76 ISPs. Again, I don't think there's been cooperation among people in general of that scale since, like, what, the Y2K bug? It's crazy how big this was, and all the sort of historical charts that I can find in terms of like IPv6 usage on the general internet from websites like Google, Facebook, those sorts of things. Basically, before 2012, there was almost no IPv6 traffic. But starting in June of 2012, for instance, Google was seeing somewhere around 0.3-ish% of its traffic using IPv6. By the end of, well, by nowadays, by 2020, we're up to a little over, somewhere between 30 and 35%, depending on the day of the week. It seems to spike on the weekends. So but yeah, that was just an absolutely crazy sort of amount of coordination that I've frankly never heard of people pulling off before, and really cool and impressive, and something really interesting to dig into and see what actually went down. Right, so finally here I want to talk about sort of where we're at in terms of IP6 and some like predictions on where we're going. So at this point, practically all the cloud providers are providing IP6 by default. A lot of ISPs provided by default, and everything just kind of works in that case. you can see that from the graphs from Google and Facebook in terms of like the usage is spiking practically every weekend. And so at this point it's kind of just being assumed to already be there and kind of just waiting for the applications to support it, for the admins to support it, and it's here. Like, it is here. It's a first-class citizen, and it's going to happen in the next couple of years, where we're going to hit more than half of the traffic in the world is over IPv6. Already you can see Facebook is seeing 60% of traffic from the US using IPv6. From India, that's at 64%, sort of developing markets in and around India, and sort of that giant market that's sort of coming online for the first time. Their IPv6 usage is like, it's the majority. It's sort of so it makes sense that it's the first-class citizen for people getting online, especially via mobile connections, 4G, 5G. It makes sense for so many devices to be IPv6 first, and carriers to just be using NAT for their IPv4 legacy support is the best, is what you can call it at this point. There's a lot of basically at this point we just need the network admins to get off their butt and get it implemented. I know it's not as simple as that. It's not as simple or straightforward as that, especially if you need to be using the same kind of physical infrastructure as you're using for IP4. Because some of the design sort of considerations are a bit different. But if I'm implementing a brand new network these days, if I'm getting things up and off the ground, IPv6 is probably going to be my first consideration, and then IP4 can just be sort of almost an afterthought, and just use that for basic functionality. Like, it makes things so much simpler, because you don't need all these crazy NAT things, you don't need port forwarding or anything like that. It brings firewalls back to just being firewalls, so, and not having to do NAT, not having to do port forwarding, anything like that. And yeah, it's here, it's ready to go, and it's time for us to start actually implementing it at all the smaller sites.